Hello, ladies and gentlemen. I hope you're all doing well. We're going to be taking a look at another one of the COMC papers, the Canadian Open Mathematics Challenge. And this time we're going to be looking at the 2015 paper. So if you want a copy of this contest, you can click the link down in the description below and get a copy to try it out for yourself. So let's take a look at the paper itself. We'll just be taking a look at question number 1 in this video, but of course, let's take a little bit of time to poke around the instructions. First thing you might see over here on the side, no calculators, which means my beloved pink tie calculator is going away. We're not going to touch that for the duration. Okay, so that's an important thing to know. A little bit of a distinction. The Open, I believe, used to allow calculators, but of course they made a switch there in the past. So there's 2.5 hours to complete the paper, so if you actually want to print it out and try it on your own, it's good to set a little timer for 2.5 hours. There's 3 parts, an A, B, and a C. The questions get harder as you go along, and the marks change to match. Another important thing to note is the first 8 questions, so the 4 from A and the 4 from B, you just need your final answer. They say that somewhere. I think, yeah, down here. For sections A and B, it's not necessarily work. But for C, we're actually going to have to write out, show our work, justify things. If we use the Pythagorean theorem, say the Pythagorean theorem. If we're going to calculate the volume of a sphere, we should write down that formula so they know what we're talking about. Okay? And, if you want to read the rest of this, by all means, go ahead and do so. It's important to know the rules for any contest you're going to write. But I leave it to you because we're not going to exactly be writing it under contest conditions because I'll be stopping and explaining things, and we will likely go over time, even if you string all the videos together. Anyway, so we're going to just look at question number 1 in part A. This should, in theory, be the simplest question on there, and as you can see, we just need the final answer for this one here. But if we think we're going to screw it up, or that we have screwed it up, we can show our work and maybe get some part marks. Maybe get 3 out of 4, or even just 1 out of 4 if we really don't know what's going on this one. Okay, so a palindrome is a number where the digits read the same forwards or backwards, such as 4774 or 505, because if I list the numbers out, 4774, and if I went backwards, 4774, I've said the same exact thing twice. For example, here, 2015, not a palindrome because it would go 2015, but read backwards it would go 5102, not the same thing. Okay, so we're being asked, what's the smallest palindrome that is larger than 2015? Okay, now if you haven't seen palindromes before, they're a useful thing to sort of play around with. But if I'm looking at a palindrome and I tell you, oh, by the way, this is a 5-digit palindrome, and I say the first 3 numbers are 1, 2, 3, you don't ever wonder what the remaining 2 are. Because it has to be read the same forwards as backwards, so it has to be 2 and 1. Okay? At the same time, if I'm looking at, say, a 4-digit one, which we will for this question, and I know the first little bit of it looks like 3 and 1, I automatically know the last ones are 1 and 3. And it's not just about the first bit. Okay, if I know I've got a 1 here and a 3 here, and that it's a palindrome, it sort of has to be filled in this way. Okay? So how's that going to be useful when we look at this question? Well, we're looking at numbers more than 2015. Now, I suppose you could say, okay, 2016 is next. Is it a palindrome? 2017 is next. Is it a palindrome? But that's not really going to be productive. Okay? You're just going to be writing out a whole lot of numbers saying no, 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 no. So let's instead think, okay, 2015, that's kind of a low number in the 2000s. Now, why am I talking about the 2000s? Because it's a 4-digit number. We want a palindrome. And so we might consider the first 2 digits, the 2 and the 0, that tell me I'm in the 2000s. It's 2000 something, 2015, 2037. So if the next largest palindrome beyond 2015 were in this range, knowing these first 2 digits would sort of force it to be 0 and 2. But of course that's less than 2015, so that didn't work. So we can go through all the 2000s, we'll never find another palindrome. How about if we go beyond? Well, what's beyond 20 something something 21 something something, and that is going to give us a number that's bigger than 2015 and is a palindrome. So there's our final answer. I'll leave it there, but of course on the actual day of, you would write it in 21. You'd write it down in the booklet just like you would on like a Euclid paper or any other open. You just need to put your final answer in the box, and no one will check the work that you wrote here. But if your final answer down here is wrong, you want to make sure that what you've written in this area is nice, neat, and clean. Okay? But that does it. We're going to continue on with our open paper. I will see you for question number 2 in part A in the next video. Until then, have a wonderful day and take care.